Welcome to API Nightmares, building the worst API possible just so you don't have to. And before we get started, my name is Marcel. I'm a solutions engineer for EMEA Systems Engineering. So I work with our large customers, with our large partners on all aspects of APIs at Cisco. And in that position, I get to not only use a lot of APIs, both from us and from external or third parties, but also get to build and architect quite a few. And with the rise in popularity of APIs and with like pretty much every business these days offering an API to their customers, API experience has become much more important, right? People build entire product on top of other people's APIs, so the API is the product. This has led to roles like API architects being created, and there's a lot of best practices around how you can build a very good API. But what if that is not your goal? Maybe you do not like your job as an API architect. Maybe you need to get laid off in order to finally pursue that Broadway career. Or maybe you just don't want a good API experience, because with a good API experience, people may be using your API, and maybe that is not your goal. So in today's talk, we're going to design the worst API possible, and we're going to have a look at a few steps you can take if you do want to have a very, very bad API experience. And maybe even if you're aiming for a good API experience, you do see a few anti-patterns here and there that you may have in your current API. So let's get started. And let's start with the obvious entry point, which are the endpoints of our APIs, right? This is the first point of contact for every user. And this is pretty much the starting point of everything, right? Everything evolves around the endpoints that we're going to be designing. Just to be clear, I'm going to be focusing on RESTful APIs, on REST APIs here, right? We want to be designing a bad API. We don't want to be evil and doing things in SOAP or anything of that caliber. So when we look at the endpoints, we have two different entry routes, right? We can first off look at the paths, right? The URLs that people would be using in order to do something or to interact with your API. And then we have the payloads, the stuff that people receive back and the stuff that people have to send you in order to do something with your API or with your REST API. So let's have a look here. And this is a payload of what I would say is a pretty reasonable API, right? We're obviously searching for some sort of users and trying to scope them by our country, which is in this case Germany. So we're searching for all of our users who are situated in Germany. And then one of the replies might look like this, right? We have a first name, last name, username, and then some nested entities like the address or the phone number and these kinds of information. And this overall, right, it's a pretty decent API design. It looks pretty much up to what you would expect from a modern API in today's day and age, I would say. So how can we make this a bit more, let's say, nightmarish? Well, first off, if we're offering the user the ability to search, and it's quite a common thing, right, to do, we do want to have these query parameters in a well-designed API. They make it super easy to, in this case, even look for some nested stuff like, okay, we want to search for all people that are in the Berlin area. So first step, let's get rid of that query parameter, right? Let's do not allow the user to purposefully or use anything in the API to do these kinds of more advanced lookups, these more advanced searches, right? The endpoint should just dump the data back at you. So nightmare lesson learned here, searching is listing and iterating, and it's best done on the client, right? Your database system might have search indexes and all of these kinds of things built in, which makes it great for searching, which in turn means for us designing a nightmare API that we do not want to allow the user to be off the hook that easy. And talking about databases, your query might look like the one, or the stuff that you're presenting to the user might look like the JSON payload we just saw, right? With the address and with the phone number already listed, because that is what your interface might quite often be querying, right? Showing maybe a table or a directory table or stuff like that. And this might be what your users are requesting quite often. Your database table might look like this, right? This is your database, maybe, hopefully I do not have access to your database, but you might have the address and the phone numbers linked as foreign key relations. And while that might make sense from a database point of view, from a user point of view, it does make sense to get all the data in one response that we actually are going to be using quite a lot, right? We don't want to have underfetching. We don't want the user to have constantly sent more and more requests in a well-designed API. So in our Nightmare API, we're going to go the other route. We're going to add endpoints for addresses, and we're going to add an endpoint for phones, and then we're just going to give the previous queries. Now, with these steps, we've already made a quite easy task like, oh, make a search interface that shows all of the people that are in Germany much, much more difficult, right? Not only do we now need per user where we show all the information, 3 requests, right? 1 user request and then a subsequent request to the addresses and the phone numbers. We also made searching near impossible or much, much more difficult because you now need to search all the addresses for all the addresses that are in Germany and then correlate that back into the request or into the search in the users. So lesson learned here, don't give the interface what it needs. Give it your database layout. That's much easier anyway and has become quite easy, especially if you're using an ORM like Django, right? Exposing your database layout as an API and not paying attention to what the API should actually expose is quite or has become quite easy. Now, with that, we can go one step further and we can make the payload itself, right? What we're sending back actually a bit more unusable. And the first point we can do is we can change the consistency of the cases and stuff for our parameters, right? Instead of having them all as camel case, we can do like, last name or in snake case for the username, mixing and matching. And this is actually something that can be happening quite often if you're using an API gateway, for example, that merges different backend services into one API response. Why make the work and actually normalize all of the properties? We might as well just leave the user with user underscore name and last name in a different case. And while these are quite obvious and quite visible examples of these kinds of inconsistencies, even more devious are these kinds of things, right? Booleans, where some of them are prefixed as enable user and the other one is enabled calling, right? That one D in there, which introduces a lot of inconsistencies, makes it hard to reason, hard to predict what the property in the API will be called, and thus makes the developer experience a lot more difficult. So, and then we can also introduce inconsistencies between our API endpoints, right? And the names of the properties and the way that we name the API endpoints, right? In this case, I have renamed users to user profile, where best practices would have us use the plural, so user profiles. I still have my addresses, which is correctly in that sense named. And then I have phone underscore number, which again is not a plural and also suddenly uses snake case instead of camel case as the other ones. And we also have the phone property, which is now still called phone, but the endpoint for that is phone number, right? These kinds of inconsistencies make it very, very hard to reason and to really use the payload easily. So the lesson learned here, inconsistency really is the key to bad API design. Apply to attributes, apply to endpoints, and pretty much everything in between. Whenever you can be inconsistent, be inconsistent. Then we have things like the link properties, right? Maybe someone has come up with the idea that you definitely need Hateos, so hypermedia is the engine of application state in your API. And they're like, let's introduce these links. And in fairness, these links could actually solve quite a few problems with that nightmarish API design before, right? Because instead of me now wondering what is the correct endpoint to look up the foreign key with the phone number, right? That phone maps now suddenly to phone underscore number. Well, I can just look at the links below and use that as a sort of way to navigate my way through the API, sort of as the intended idea behind Hateos, right? Now, so obviously in our Nightmare API, we do not want to offer these kinds of easy to use ways to navigate around the API. And if someone really insists on using them, if someone really says, oh, we definitely have to do that, at least make the link format non-standard, right? Don't use RC 5988, the web linking standard, or hypertext application language, or any of these kinds of standards that exist out there to format these links. Just run with your own, right? You want to be inconsistent not only within your API, but also within the industry. So the lesson learned is Hateos is for people who build usable APIs, so don't do it. All right, so we have already done quite a lot of damage with just the endpoints and just the payload in terms of what we can do, but we can take that actually a bit further. And one of the best features in REST APIs really is the fact that we have this one-to-one easy mapping between create, read, update, delete operations and the HTTP verbs, right? We use get to retrieve stuff, we use post to create stuff, we use delete to delete things, and then we can use patch put to update stuff. And by that, we can very, very easily map CRUD operations into what we want to do in our API, and also make it very intuitive, right? You intuitively know, okay, this endpoint, if I do a GET request to that endpoint, I should get a list of all the resources that are behind that back to me, right? And then if I do like with an ID, I get the details for that specific resource that I'm requesting, that I'm specifying via the ID. And then sometime you see it down there, you do have these controllers or these actions, so these additional operations that you want to do, and then you can just append them like /promote, for example, which would, I don't know, for example, promote a user profile to moderator or whatever your backend is actually doing here. Now, the point with this is that this makes it easy and intuitive to use. And we have already learned that easy and intuitive are two of our main enemies here. So let's get rid of all of these different types of requests, right? SOAP can get by with one of them. GraphQL can get by with one of them. So we're only going to post in our entire API, right? We're going to map all of the different workflows onto post requests. So the only requests that get through our API are going to be post requests. Just to infuriate me, we're also going to replace the path parameter ID with a query parameter ID. This isn't necessarily a very wrong design. This is just something that riles me up personally. And now, right now, we can only post things. And if you would still think in like proper API designs, this would mean that right now we can only create things. So we need some way to specify what kind of action or what kind of method we want to invoke on our API in order to still allow for get workflows and still allow for delete workflows and these kinds of things. So in order to do that, and instead of using the pre-built HTTP verbs, we're introducing an action parameter. So for example, action delete, action list, action get. And that way we can put all of the different actions that we want under one single HTTP verb, under post. Kudos for you. And if you're now thinking, hey, maybe we should also change the name of that query parameter, right? In some endpoints it might be action, in the other ones it might be method. Congratulations, you're thinking like a nightmare API architect already. So if we really wanted, everything can be a post, right? So with all of these steps that we have taken so far and all the lessons we've learned along the way, we have done two things. We have made it increasingly hard to make properly formatted and properly defined requests to our API, right through all of the inconsistencies. And we have also sort of ballooned the number of requests that a user has to do to carry out the types of workflows that they might want to do. So this, going forward, is going to be the basis, sort of like the foundation of how we can then take that to the next level. And how can we take faulty requests to the next level? Well, with errors, because a faulty request quite reasonably will trigger an error, and error handling thus becomes very, very important to us, right? Or to us, and with that I mean the poor soul who has to use the API that we're designing right here. So let's have a look at who needs errors anyway. And similar to how the HTTP verbs are used so well in REST to naturally map to create, read, update, and delete, and sort of builds on top of that HTTP standard to make it very easy to do this kind of mapping. The HTTP standard also has these great status codes, right? The status codes allow us to, by only checking one single number, understand if a request or a response was successful, right? If a request was successful, we can just check the status code of the response and understand, is that the correct thing that we're doing here? And In a successful response or in a well-designed API, we would be doing something like this, right? We would be sending back a 200 OK header or a 200 OK status code in case that our response or our request was successful. And then in case it wasn't successful, we could be sending back a 400 bad request, for example, with a payload that specifies an error code, a message that is very descriptive of what is actually wrong, right? In this case, that our username is a required field and that is obviously missing from the request that we just received, and also a tracking number or some sort of tracking thing that we can use in order to trace a request through the logs in our own system, right? If the developer reaches out to the API support team, for example, with that number, they can quite easily go into the backend and search and understand what actually went wrong with the request. And by using those status codes, you can use the API without reading the docs and still understand when there are errors, right? And you can just use the status code and understand, okay, if this is a 200 OK, everything is fine. If it's a 400, something is wrong. So we do not do easy. We do not do easily digestible. We do not do consistent. And we also don't do consistent with the standards. So instead of sending back the proper status code, let's send back a 200 OK all the time, right? Every request comes back as a 200 OK, which will now force the user to always check, was it actually a successful response? Or did the request fail and it just came back with the status code, which of course is a bit of a hassle. Huh? So status codes are bad. We always want to fail successfully. Then we have those status codes, right? These codes that actually give the user some sort of insight into what is actually wrong with the application. You could have a table in your documentation that says, oh, this error code maps to this specific wrongdoing in your request, or this wrong response or wrong request on your part. So by doing that, we make it easy for the user to look up what he or she might have done wrong in the request. So let's get rid of that code, right? Make it harder for the user to understand what actually went wrong. So error codes are bad. We always want to fail without a way to identify the cause. At least the user should not have a way to identify the cause. We in our backend system obviously do know quite well what went wrong. And if you look at the previous slide, the user actually still also knows quite well what went wrong, right? There's no status code. There is no error code that could give us some insight that we could look up in a table. But that message, right, that username is a required attribute message, is actually quite descriptive, right? It pretty much perfectly tells you, as the developer using the API, what is actually wrong here. The problem with that is that you have to implement all of these different error messages in your backend. You have to think about how to properly format the error messages, right? How to do maybe some of that stuff automatically. And quite frankly, we might not want to do that. So let's just send a very generic error message like wrong request. All right? This error message pretty much handles 100% of all your errors because you can always send it back to the user and say, yeah, there's a wrong request. So that's a pretty big time saver for your development time. I would say, so lesson learned here is keeping your errors as generic as possible saves you time in development, right? And as a nice byproduct, does make it quite difficult for the user to understand what is actually going wrong, right? What did I do wrong in order to deserve this error being served up to me? Now, at that point, a user might turn to your support system, right? To your developer community, to your support channels, to your technical assistance centers, these kinds of resources that are able to troubleshoot based on, for example, the tracking ID, right? The tracking ID would make it quite easy for the developer support team to look up that ID in your logs and see, oh, my API gateway threw an error that says, hey, you're sending a wrongly formatted request. Username is a required field. They could pass that information back to the user. So not having that tracking ID makes it even harder, both for your support team as well as your developer audience. So let's get also rid of the tracking ID, right? We do not want to offer the user or the support team any easy way to get to get visibility. Because a lesson learned here is that tracking codes make it easy to find logs. And what's the fun and easy, huh? Like, let's make the support team and let's make the developers really work hard for using your API. So we've covered endpoints. We've made the endpoint experience, and we made the request experience and the responses that we get quite bad. And if you have a wrong response, which we're triggering with this, we have also made the error experience quite bad. Now, I did mention a second side effect, and I sort of glossed over it a bit, where I said we are actually also increasing the number of requests that we're making the user do. And how can we use that to our advantage? How can we use that to make the API experience as miserable as possible? And if you think about it, we actually do need to do that, because all of the things that we did so far could be remediated by, a developer writing a client. If they are desperate enough to use your API, they might write custom code, custom SDKs that deal with all of these limits, right? That maybe do a unified model for all of your endpoints that map your user underscore name into a proper username entity, and so on and so on. That offer native search capabilities by implementing that lookup that we did, where you just list all of them and then you have to search. Wouldn't make it fast, but would make the developer experience already easier. And it's something that you might see if your people are desperate enough to use the API. So how do we turn the maxed out number of requests, or the multiples of requests that we are making the user send, into real misery without shutting down the API? Because we could just shut down the API and that would of course make it completely unusable, but we want to make it barely usable. Well, the magic word here is rate limit, right? And knowing a limit that you as a developer do not know. And pretty much every developer will accept that rate limits are a necessary evil, or something that you have to do in order to ensure service stability and in order to ensure, for example, also billing depending on how you monetize the API, right? So developers in general, I would say, are okay with rate limits as long as they are reasonable and they are predictive, right? And they are consistent. So you already know where we're going to attack here, right? So you might have something like this in your docs where you have say, hey, we need rate limits to ensure a proper service level. And we're going to handle rate limiting requests by sending you a 429 too many requests response when you're exceeding your rate limit. And in that response, you're going to get a retry after header, which is going to tell you how much time to wait in seconds. Right, so a response might look like this: 429 too many requests, and a retry after header. And this is actually quite usable, quite easy to use, because now we know how long we can wait, and we know that we have to retry the request. Well, we always fail successfully in our API, so let's replace that 429 with a 200 OK, and we are just sending an error message that says too much. Now, here, we're obviously still including the retry after header, and we're just still giving the developers some sort of predictability on how long to wait to retry the request, right? That makes it very easy from a code perspective to just, wait that time and then requeue the request and redo the request and see if it then goes through. And we don't want easy, so we're definitely going to get rid of that retry after header. And we're also getting rid of that section in the docs, or maybe we're not getting rid of this section in the docs, depending on how inconsistent your docs should be. So lesson learned here, there's beauty in opaque numbers, right? Why tell the user how long to wait? Next up, you might have in your rate limiting is some sort of upper limits, right? You have either dynamic rate limiting, which does rate limiting based on the load on the backend and these kinds of things, or you have some strict rate limits of like you can do 100 requests per minute, or you can do 60 requests to that specific endpoint. And by giving your user upper and lower limits, they can actually calculate, oh, my HR workflow needs to create 1,000 user profiles. So using that lower limit, I can calculate how long that is going to take, right? I can predict how long that workflow, just the part of your API, of course, is going to take, right? We don't want predictability, so we're definitely going to get rid of any upper or any lower limits. And we want to be consistently inconsistent. That is the way to go for our rate limit so that we can achieve the maximum amount of unusability. The last step is what happens if one of your users dares to exceed your rate limit. Well, off with their head, obviously. We are disconnecting them. We are deleting their token instead of just setting up the retry after time much, much longer. They are obviously not respecting that number anyway. So that way, we want to be draconic, right? It's driving up your whatever cloud provider you're using bill after all. Now we've covered rate limits, we've covered endpoints, we've covered all of the code part of this, but there's also the visibility part of this, right? The docs that actually let you use the API and understand how to use the API. And in terms of docs, the best docs is no docs, right? The best doc to have is not having a doc at all, because the documentation makes it easy for a user to actually dive into the code and actually understand what is going on with your API. Now, if for some reason, maybe an RFP or some requirement, you do have to provide a doc, you might have something like this, right? Some wiki page, maybe a PDF document, a Word document, something that is not searchable, something that is not easy to find on the web, something that is really, really as far away from the standard as you can be, right? Standards are there to be broken. Run your own. What's a swagger anyway? It's a weird word. You don't want to do that. Now, I showed that user profile really, really quick, and maybe someone actually noticed that there's another anti-pattern in there, another great lesson learned for us to do a nightmare API. Look at the username. In our request, the username was in snake case, right? And in the docs, the username is in just all in one word. So having inconsistency between your docs and what's actually being returned. And the best way to introduce that is not by going either you first design the contract of your API and then you generate the code based on that, or you have the code and you generate the documentation based on that. Don't do either of these ways, because if you do either of these ways, you're going to have consistency between your docs and you're going to with your actual code that's running on the server. You don't want inconsistency. Inconsistency is key here. So don't generate your docs from code or vice versa. That would make them consistent. And then the last part is the change log, right? How do developers keep up with changes to your API? This is super nice, where you can subscribe via RSS, where you can subscribe via email and actually understand which of these changes are breaking changes, which of these changes are new to the API, which are deprecations, these kinds of things, right? Making it easy to understand what changed in your API and when breaking changes, for example, are going to take effect. A different model is just doing this on social media, right? Having your developers complain that you changed the username attribute or a user profile. So you go for error-driven change logs based on your social media channels. With that, we have pretty much covered a blueprint of how to make a pretty bad API and how to ruin the API experience every step of the way, right? From the endpoints to the errors, to the limits, to the documentation that people are actually going to use. And all of these factors boil down to two things, right? Consistency and predictability. You want your API to be consistent or predictable. Or if you don't want a good API, you want them to be inconsistent and unpredictable. Going back to that beach of sanity, I want to say, all the lessons learned in this talk obviously are aimed at showing you anti-patterns that might exist in an API that you are using or that might exist in an API that you are building. And even small things like that little d in enable versus enabled in your API attributes, right? In your attributes of your response can already adversely affect the user experience. Bad rate limiting, bad error response codes can affect the user experience. So if you want to be good about this, take everything you have seen in this talk, do the opposite, and I'm fairly certain your developers will love you for that. That being said, thank you very much. Thank you for being here for this talk. Thank you for being with us for Cisco Develop. And I'm really looking forward to seeing what all of you are going to build. Hopefully not by taking literally what I said in this presentation, but by doing the opposite of that And yeah, thank you very much.